Let's take a look at the rigid axle suspension. In a non-independent arrangement, the wheels on the front or rear of the vehicles are connected usually by a tubular axle or a beam axle, like what we are looking at right now. There's a tubular axle there or a beam axle. The wheels at the rear. Because of this, the road wheels are able to keep good contact. This layout of the layout on this type of system is very simple and very strong. So there is strength there. A rear axle suspension, that's a rigid axle suspension, is stronger than independent suspension, which makes it suitable for larger or heavier vehicles. So trucks and other heavier vehicles normally have non-independent suspension, including HGVs and buses, as well as other off-road vehicles, such as Land Rovers, where the strength is important. A disadvantage of this system is that the movement of one wheel affects the wheel on the other side. So when one wheel moves due to a shock, it also affects the other side. So the shock is actually felt throughout the body of the motor vehicle. This can have an adverse effect on the vehicle's handling. So the handling of the vehicle will be a bit more difficult because of that. Three advantages of rigid axle suspension are that it provides good wheel travel, axle articulation, and ground clearance, which are essential attributes for off-road use. So it is basically more suitable for off-road use in very rough roads. Yes. Then let's talk about independent suspension, like the one that we have in front. A independent type suspension offers many advantages over rigid arrangements, such as each of the road wheels are able to move independently of each other across the axle. So the road wheels there, they move independent of each other. The shocks felt on the left are not transmitted to the right, and vice versa. Because of this, the road wheels are able to keep good contact with the road surface and maintain excellent wheel geometry during cornering. These benefits provide additional comfort and improved vehicle handling, which in turn provides a safer vehicle. Okay, that's where independent suspension is concerned. Then just a short comment on unsprung and sprung weight. Large unsprung masses on a vehicle are undesirable as they have a negative effect on vehicle handling and behavior. For this reason, vehicle designers try to keep the unsprung weight as low as is possible. Low unsprung weight helps to produce a suspension system that responds sensitively to road irregularities. So I think we're mentioning this for the second time. Unsprung weight has to be as low as is possible. There is a type of independent suspension. That's a type of wishbone type of suspension. We call it a wishbone. We've got an upper and a lower wishbone. Then the damper is in between there. The dampers are in between there. Then that's a rear independent suspension. This one is a rear with a trailing arm and pivots. Then there's a spring there and a damper. Well, that's a drive shaft. That's a drive shaft, and that one is a differential. That's a differential. The purpose of the differential is to turn around the drive by 90 degrees, allow wheels to turn at different speeds, especially when taking a corner. Those are some of the features of a typical suspension system.